I'm Sarah Perkins-Kirkpatrick.
I'm Iain Strachan.
And this is Totally Cooked,
The Climate and Weather Podcast. Today, our guest is Dr Joyce Kimutai from Imperial College in London. Welcome to the show, Joyce. It's really great to have you with us.
Thank you so much, and thank you for having me.
Sarah, I am giving you the first formal question
You
today.
are.
I could just kick back and not ask anything today because you two are deep into what we're talking about, but I'll let you have at it first.
Okay, so Joyce, we have a fancy word in the world of weather and climate science, which is attribution. Many members of the general public won't be familiar with this concept. Can you tell us what attribution means to you?
It's a field of science or a subfield of climate science that tries to understand the role of climate change. And it can be very specific to even say anthropogenic climate change, so the human-induced climate change in trends or extreme weather. So you could be looking at events in general, or could just be looking at long-term changes in the climate system. And basically, you're just trying to understand to what extent is climate change explaining how those trends have changed or how those extreme events are happening. So it could either be in terms of the frequency in which they're happening in the current climate, or it could be the changes in the intensity or how intense or their magnitudes in the current climates. So basically, you want to understand the way these trends have behaved or the way these events are happening and their probabilities of occurrence. What is the role of climate change? What is the role and the contribution of climate change?
And do we have, do we use historical records of things like temperature when we're doing these calculations?
Yeah, even before you touch models, you would really want to look at the observations, so the actual representation of the climate system. So even before you start simulating, you want to see what are the observations telling me, what was observed. So if you're looking at, say, for example, an heat wave, you want to see what the temperature is saying at that time. What kind of thresholds was surpassed? Is it something that you also want to link to the impacts? Were there reported impacts in that region? So you first start by putting together some information, so looking at the data and understanding that particular event. So you're using historical data and understanding over time what has actually changed in relation to this particular event that I'm looking at.
What are the limitations in terms of that available data, like accurate observations, accurate temperature records? Does that limit where we can perform this kind of work and which areas in the world we're able to do it accurately?
And that's a very good question, and especially asking someone like me, where I have been doing my research in regions that have actually had a lot of these data limitations. So you need good data. And unfortunately, the quality of data is not the same in every part of this planet. So there are parts of this planet where it's very hard to, number one, access the data. And when you get the access to the data, it might not be good. So there could be gaps, like there might have been periods in the observational record that have not been observed, maybe due to maybe poor maintenance of some stations, or it could just be because there were conflicts or there were issues in that country at a particular time. And so those stations were not maintained. And so there are gaps in the data. It could just be also because they've been changing in sites of where these stations have been. And so there's a number of issues that might have affect the quality of the data and also the length of the data. In that case, it can be a bit difficult to contextualize, understand your event, to define your event, because the data is not giving you the information of what really happened. And there's a very good example of a study that we did that affected parts of Rwanda and DRC, where first of all, we couldn't get the station data for that region. And so that means we could only use proxies, and the proxies that exist are these gridded and satellite data. But it was very interesting when we got our hands into these proxies, they were all telling us a slightly different story. So some were putting the event on a different location. And when you speak to the locals, they were like, oh, I don't think it actually rained that side of the region. And then some were putting it on different days of the event period. So it was really difficult to even say what exactly are we looking at? What are we analyzing here? Because there's no any consistency that you could rely on one data or the other.
I was going to say, that's an interesting case of where you're trying to use satellite data as a proxy for incomplete or inaccurate observations. Are there similar kind of ways that you can fill in the blanks when you're looking at historical climate that you don't have good observations for? The word that's emerging in my peripheral vision is reanalysis, but I don't know if I'm on the right track or not because I'm not a climate scientist. Is that something that you can use to look into the past?
Yes, that's the other product that you can use to look into the past. But I think one thing that is important to say is that if you don't have good enough in situ or the station data, it means even if you have these proxies, they wouldn't be any good. So station data are used, they're incorporated into this in situ to sort of give a representation of the region. And so if you don't have, if it's not good quality, then it means the proxy itself is not quality either.
And I suppose we should clarify, because I'm conscious that we've got two attribution people on the call and one person who's now getting too involved in this. And I need to take a step back a bit. And, for people who are listening who aren't meteorologists, who aren't climate scientists, when we're talking about station data, we're talking about, weather monitoring stations, right? Physical locations that have temperature gauges and rainfall gauges. Is that the case?
Yes. So we are talking about on the ground stations and measurements. So you have sensors on physical locations on the ground taking these measurements.
The examples we've been talking about, so, attribution of heat waves in, say, Europe or in Australia, which Sarah does. Station data, I imagine, Sarah, is in Australia are stations all operated by the Bureau of Meteorology or some of them operated by other entities? Who runs them here?
Okay, so first of all, the high quality ones are operated by the Bureau of Meteorology. They have actually a wider network than the ones that we deem high quality, but that doesn't mean that people don't have weather stations at home that can be used in data sets or, citizen science projects like Weather Underground, which can still be informative. But certainly when we're talking about the high quality station-based or in situ data that we use to understand climate change and weather recordings and all that is all owned by the Australian Bureau of Meteorology.
And then contrast that to the example you were mentioning, Joyce, in Rwanda and Democratic Republic of Congo. I imagine the situation around access to and maintenance of high quality weather stations is quite different.
Yeah, it's not very different because it's mainly actually by the National Meteorological Agency. But I think and you could have other observers, even the case in Kenya as well. Like you could have, as Sarah says, private observers or volunteer observers. So people that would be observing the weather in their own sort of, whether they are running a farm or a conservancy or whatever. But the problem is that if that data is sort of not incorporated in the sort of the main database that is run by the Met agency, so you find that it's very scanty. And sometimes it will just be available in print form or just machines that are private machines that are located in that organization. So they're not part of any database that can actually help sort of do an analysis of a region. Of course, you can go to them and they can give you the data for that they have, but you only have. But if it's not incorporated in the database, it might not be very useful, especially if you're looking at a wider region, trying to understand the climate of a wider region. But coming back to your question, I think, as I understand, for DRC and Rwanda as well, is that it is managed by the Met Office, but because these countries have had issues of conflict in the past, of just a bit of instabilities in the past, you find that there's not been sort of consistency in maintaining these stations or having people man these stations continually, because you need a lot of sort of resources and people being actually present. Of course, you could have the automatic weather stations, but still, even for that, they'll still have to be maintained. So it requires sort of that consistent, sustained efforts of making sure that these stations run and transmit data. And so you find that for these countries, there've been periods in history, in the historical period, where they've been a bit of gaps due to issues that they've had. But the other thing as well could be that if even for Met agencies where, and this is it's not just the case for Africa, is that there's still very restrictive data sharing policies. So it's you can't just write to the Met agency and ask them for data, and they straightforwardly just respond to your email with an attachment of the data. It's a very long process of getting the information and of getting the data, and even in most cases you don't get it. And especially for us in our team, where we want this data very quickly to like look at events. It often doesn't happen in the sort of the timescales that we operate in.
I think it's also important to highlight, like when we're looking at an event, whether it's a heat wave or an extreme rainfall event or whatever, it covers an area larger than just one point. So this sort of in situ data set that we're talking about here. So often we do need a product that is beyond that, so uses that station data, but somehow incorporates it to a larger spatial area to fully understand both the spatial extent and the time or temporal extent of that particular event. So while that station data is so important to make sure that data is of high quality, it's often not the end product that we need for these sorts of attribution assessments.
Yes.
Going back to something, I mean, you've just touched on it there, Sarah. Joyce, you touched on it at the start of the conversation, but I think it would be good to focus in on what kind of, in your case, Joyce, extreme or high impact weather events can we do attribution studies for?
I mean, we can do for most events. It's just that sort of the level of confidence and sort of the ease of doing it with sort of the tools, the availability of tools to do it. And when I say tools, I mean if we have the data, if the models are good enough for that event, if we have the expertise as well, because some extreme events, the expertise is not just. An example could just be like wildfire. This is sort of a new event that we don't have like a lot of expertise in this area. So there is a number of factors. So it's possible to attribute a number of events, but what differs is sort of the confidence or the ability to attribute them confidently.
And so what are the more straightforward ones or the more common ones that you do?
I think the common ones that we do, one of them is heat waves. This has become almost one of the almost straightforward ones to look at. And I think the reason is just because it's the link with the warming is almost very linear, very straightforward. It's complex in other ways, but I think just that because having that very linear relationship or like very close understanding of what exactly would the warming of the planet mean for heat waves is one of the reasons why it's one of the almost the easy ones to do.
I would agree with that. Like it's almost to the state that it's boring now. Like we know every single heat wave that occurs now has a signal of human-induced climate change behind it, like without a doubt at all. It's almost boring to do it because it's not interesting. There's not this sort of challenge of teasing that signal out and working out that exact role. Like for each heat wave, that signal would be different. It's very bespoke and unique, but there is always a signal from now on.
Yes.
You heard it here first from Sarah Perkins-Kirkpatrick. Heat waves are boring and easy to do. Anyone could do it.
You know what? I'm not the first to say that about attribution.
I was just going to say that I think we've warmed our planet enough and the change is substantial in a way that for heat waves, it's just very evident and it's very clear and we can see it.
What about heavy rainfall and flooding? Is that a bit more complicated?
Yeah, so that can be complicated, and that would really depend on where it's happening. What data do we have? How good quality is the data? But also what kind of an event it is. So it could be very localized. I mean, it covers a very small area, and especially for models to capture it can be a problem. It's relatively not as straightforward as heat waves. But it's really so much dependent on what tools are available to use to attribute and what region. And so when I say tools, it also could mean what regions of the planet this is happening, because also that really sort of almost determines whether models will do well. So if it happens in a small island state, for example, we know that some models don't see any of these seeds at all. It sees it as part of the ocean. So I think if it happens in Fiji, it might be almost impossible to do it. I mean, but Australians would know this better. But just saying for these small island states, it would be difficult to do. And so, and the case as well, if it's a very localized event, it might be difficult.
We talked a little bit about climate models with Andrew and Aditya earlier today in our Net Zero episode, and it's definitely becoming a pressing need for us to do a climate models episode because they're so important to the science. But just to clarify for people listening at home, why is it that climate models struggle with storms, which are those small scale events? And, you mentioned there that some climate models don't actually recognize island states. And, this is a question for either of you. Like, I know the answer, of course, but I'm not the expert. So you as the experts who use these tools, why can they not do that?
It's representing some processes. So it's not able to simulate and replicate some processes that could be very fine or localized. And we use a term called parameterization, which is just sort of almost saying oversimplifying a process that can like sort of almost break down. So it's like, instead of like saying, I want to understand the number of houses in this square kilometer by square kilometer, and getting the details of what rooms and what doors and what, you're just basically saying, I'm just going to count the number of houses. So you're just almost like oversimplifying the information that is coming out of that and not getting sort of the most nitty-gritty or the detailed bits of that. And so for most small models, very small scales, they can't really sort of replicate that process or represent it properly. They almost sort of like simplify it in a way to give sort of like, let's say, a rough representation of that region instead of giving like the individual smaller, finer details. And so that's the issue with like when you're simulating a storm, it wouldn't be able to give the very exact details of the storm, but it could just give like a rough estimation of what exactly is happening in that grid cell.
Properly simulating rainfall is something climate models have struggled with forever, basically. It was a problem when I completed my PhD over 15 years ago now, and it continues to be an issue. We are getting better because we're now starting to build climate models that operate on scales on which rainfall occurs. So these are models that can simulate convective thunderstorms, thunderstorms that occur over, kilometres. But we're just not quite there yet in running these models over large areas and for long periods of time. So because they can't do that, and because a lot of the models that we use in climate science, including attribution, can run on tens or hundreds of kilometres, they have to estimate or guess these sorts of rainfall events. And it is a common problem in large-scale climate models that they drizzle all the time. So, living in a place like Australia, for example, and I can't speak for Africa, but I would assume it might be the same. When it doesn't rain, it doesn't rain at all. There's no drizzle, but when it rains hard. And that's something that climate models struggle with in these regions of the world.
And I think we've seen that a lot now, even with climate change. So we are seeing these I can speak for Africa, for example, and particularly Kenya, is that so we have two main seasons. There's one between March and May, March, April and May. And then there's another one in October, November, December. So it's more like a bimodal sort of two rainfall regimes in a year. What we see now, especially with the earlier season, is that when it rains a lot. So like you have a very short but very intense rainfall. So you have a very very poor distribution of rainfall in space and time over the season. And when it dries completely. It's been a trend, and we've seen this over the last 20 years happen quite substantially in this region, where we have this season being very intense, short and intense, or almost completely dry in some months. So the month of May, for example, could be entirely dry, but then you have these storms in March and April.
I was just thinking, so Joyce, one of the objectives of our Centre of Excellence, along with our collaborators at Access NRI, which is Australia's national climate simulator, one of our objectives is to develop 1 kilometre scale resolution. And I feel like we should start calling it Australia's next top model.
Why have you never said this before until now? Can I just also say that the Access climate model is Australia's only climate model, which I think speaks volumes. It's a good model and we use it a lot here, but we are very reliant on it.
Sarah, Australia's only climate model doesn't have the same ring to it as Australia's next top model. I have a real question, not a statement, which is, Joyce, you are a member of World Weather Attribution. Sarah is a special guest. Can you tell us what it is? What do you do?
Yeah, it's a collaborative initiative of scientists, not just climate scientists, social scientists as well, where we respond to extreme events as they happen. And the respond in the sense of we are analyzing and trying to understand the role and contribution of climate change with the intention to communicate that result when it's still fresh in people's minds. So basically, we want to talk about what was the contribution of climate change, whether there was one or not, when it's still fresh in people's mind and when people can still relate to it and we can still remember the impacts and they can still reach to their local authorities, either for questions or for answers, wherever. But we just really to spark this debate, this conversation when it's still fresh in people's minds. So that's what we do. It's based at Imperial College London, but we collaborate with the Dutch Med Institute. We also have the Red Cross Red Crescent Climate Center supporting us on more of the social aspects where we look at vulnerability and exposure elements to sort of have a more holistic understanding of the event. So not just looking at what happened with the temperature or the rain, but also looking at what was the condition on the ground, where were people located, was there an early warning information on time, did people receive it, did they use it? So more because we feel that this is part of the problem, and also if we're going to address the climate crisis, it has to be from all these aspects.
I think it's fantastic that it's a combination of both climate or meteorology and the social impacts. That's such a good idea. And do you know who came up with that initiative? Who decided to do that?
So in 2015, Freddie Otto, who is now a team lead and a very good lead friend called Iain, decided to establish this organization or this consortium. Tried with the first event, a heatwave. They were attending a workshop in Toulouse. I don't know, Sarah, if you know about this, but they were attending a workshop in Toulouse and there was an extreme heat affecting parts of Europe. And they were like, why not? Can we do this quite rapidly when we are still in this workshop? Talk about this here. And that is just actually how it started. And so ever since then, they've been like, oh, it sounds interesting to actually respond to these events as they happen, or even while they are still happening, and talk about them and say the role of climate change. And also the other thing is because also the public were really asking these questions as well. And not just the public, also the media. So the media would just try to understand. They would be contacting scientists or Met offices or other organizations who are doing climate research to say, can you say something about this event? Do you think climate change is playing a role? And of course, if there's no sort of an organized way of responding to that question, anyone is likely to say anything because it depends on who you ask, right? And so I think it was an important initiative in a way that we have this almost like a sort of a coordinated way of responding to some of those questions. I mean, we can't respond to all of them, but just really try to provide an answer that is based on science other than guesswork or saying, oh, because there's climate change, we think this happened due to climate change. You get what I mean? Sort of really having this sort of science-based messaging and information to the public and the media.
I am interested to know where attribution is going next. So what do you want to try and achieve in this field that you can't do at the moment, Joyce? And what do you need to acquire in terms of skills or capabilities to do that?
Oh yeah, Frontiers in Attributing Climate Extremes and Associated Impacts. That was it. It was born out of the World Climate Research Programme's conference in Rwanda in 2023. And that conference is a 1 in 10 year event. And the co-chairs, one of which is Australian, they decided it'd be a great idea to have a series of publications around the main themes of the conference, of which attribution was one. So they asked me to convene that paper, but it also included many leading experts of attribution across the world.
You having convened or led this paper, Sarah, and Joyce, you having been involved in it, what is next for what are the frontiers of attribution science?
I can't
Couldn't
remember.
Be a better place to discuss it.
Joyce will know. She's on the pulse.
Yeah, so I think it's really most of what we discussed in that paper, what Sarah wrote, or we all wrote, is really trying to improve some of the limitations and the gaps in doing science, attribution science. And most of them, I think one big one on that list was really on the data. Like we want to improve sort of the observation network, sort of the quality of the data, like just enhance the network of stations to make sure that we can collect data that is representative of regions that can actually help us study these events. So that was one of the big one. And the other one is on this issue of models that we've just been talking about as well, like how whether the community could come together to really build models that could be able to help us understand these notorious complex events that we still can confidently analyze and attribute. And the other one on that list as well, I think, was on the expertise. Like we want to improve sort of representation of what we would call like sort of undeserved like regions, or like regions that there's not been many studies done on, and also where like there's not much expertise. Because when you're doing this kind of science or analysis, what I've seen with my experience with World Weather Attribution is that if you don't have the legal, the sort of the local the local representation, or the local experts who sort of understands the local meteorology and the local climate, it can become very difficult to sort of do that remotely, and especially if you're not an expert in that region or understand the climate of that region. So it's very important to have to sort of increase capacity of scientists in places where these has not traditionally been sort of well represented.
Yeah, good summary of the paper. Thanks, Joyce. You jogged my memory there.
Better observations, better models, local expertise. We love it.
But I think that's something that was very clear for me when putting that paper together, was the observations and the issues that we have around that especially when it comes to sovereignty of observations and trying to combine them in large data sets, we're not where we should be at all. In fact, we've probably fallen behind at the global scale. So that makes it really hard to understand, not just in an attribution sense, how climate change is affecting these events, but even understanding their past changes and, you know, their trends. So yeah, there's a lot of work to be done in that space for sure.
Yeah.
And a few moments ago, Joyce, the word legal slipped out by mistake. And I think you must have been sensing what was coming, because I know that you're involved in an area of work that's known as loss and damage. And in the context of climate science, can you tell our listeners at home, what does loss and damage mean?
So in very basic terms is that these are impacts that cannot be controlled or cannot be avoided through mitigation and adaptation. So basically you put in efforts to cut greenhouse gas emissions, and you're trying to sort of almost halt or stop the warming. So that's mitigation. And then you are putting measures in place to anticipate the impacts of already the warming that we've committed, or already the warming that is happening. That's adaptation. And if those two efforts cannot reduce these impacts, so if you have impacts that would result anyway, even with all those interventions being put in place, those are losses and damages. And we are definitely in an era of loss and damage. So we are seeing these residual risks, these unavoidable impacts or losses that are affecting particularly the frontline communities of sort of the communities at the front line of the climate crisis.
So I'm thinking of examples of people who are exposed to climate change, to climate impacts, where adaptation and mitigation can only go so far. And I suppose the one that springs straight to mind is low-lying islands and nations, places like the Pacific Islands. Is that a good example of what you're talking about?
So that's a very good example that we've already, that even with reducing or phasing out fossil fuels and adapting, you might find that for these communities, sea level rise is something that will be inevitable. and it's likely to affect their lives and livelihoods and their economies. So you could find that for these low-lying regions, they're likely to be affected or to be submerged, not entirely, or maybe entirely, depending on what trajectory we take. So that's a very good example of loss and damage. And it could be other things as well, like loss of. So they are like sort of almost like tangible harms, and then they're like sort of almost intangible harms that could happen. And there are things that are reversible, and some of them are irreversible. So some people talk of loss as being a bit reversible, like we can take them back, and then damages being something that you can't reverse completely. When it happens, it happens. And some people give examples of deaths, for example. So if someone is, if they sort of a age-related mortality, you're not likely to bring that life back. Yeah, that's a loss. So it's not something that you can reverse. And it could also be things intangible, like even loss of cultural sites, like people could lose places of worship. It could also livelihoods that are no longer sustainable. For example, that for some, say, pastoral communities in regions where they are constantly being affected by droughts and they can no longer sustain their pastoral livelihoods, they would have maybe to change those livelihoods. So there's a number of, there are many forms of these economic and uneconomic losses and damages.
So what role does attribution have to play then in loss and damage?
Yeah, so attribution really helps us sort of understand how hazards are changing and in what ways they're evolving. And it's also likely to tell us with the warming, with the continued warming, with projections, where is this likely to take us as well. So basically, it's about telling us that, and I could just use an example of a heat wave, for example, so, or even whatever kind of, I'm using heat waves because this is Sarah's favorite.
Well, they're just so easy, aren't they? So
it used to be her favourite. She's bored of it now.
No, they are my favourite. I'm just saying for attribution, like seriously, any heat wave, yes, climate change had an impact. Yes. That's why they're boring in that sense. Anyway, continue, Joyce.
Yeah, so I was just going to use the example of an heat wave, saying that if we know, like now we know for sure how climate change is affecting heat waves, and we know what kind of harms are related to those, right? And we likely also, so we've seen how these has evolved. So we've seen sort of the direction in change. So attribution science helps us to understand sort of the direction of change and how that direction is change is influenced by climate change. So if heat waves are increasing, you can use the science can inform you that, and you can say like to what extent. But at the same time, it also gives you sort of an understanding of what is the scope of that. So basically, like right now, we know for every heat wave happening in the planet, there is a role of climate change to that. So you're almost giving you sort of an idea of sort of the scope and the scale of impacts that are related to these hazards that we're looking at. So it's sort of the foundational, so attribution science sort of forms this sort of foundational basis of understanding how risks are changing in the way we understand hazards. And so, of course, we know that they are compounding with, they're intersecting with vulnerability and exposure. But if you understand how hazards are changing, you can almost get a rough idea of how risks are changing in a community or in a setting.
Question, and I kind of know the answer to this, but I want to ask you anyway as our guest. When we find the signal of climate change behind a certain event, does that directly correspond to how climate change may be affecting the loss and damage caused by that event? Or is it different?
Really. No, it's very different. So, we have like almost like 3 layers of attribution. So like there's the source attribution, almost looking at what are the different contributions of warming in terms of greenhouse gases, like who are contributing to the warming. So who is pumping what into the atmosphere and trying to like sort of have like differential responsibility on that. And then you come to the hazard. So that warming itself, how is it changing the hazard? So the extreme event or whatever. And that is sort of the physical attribution or like the extreme event attribution. And then you want to go now another step to understand how is that affecting, how is that hazard now affecting, how is the warming that is associated with that hazard actually affecting the impacts? So you would have to go another step of now attributing the impacts and saying, what are the sort of the additional impacts or losses or damages that are linked to the warming of the planet. So it's not just straightforward that if you know the role of climate change in the hazard, it means it directly translates to the role in the impacts or the losses and damages.
Yes. So if we find, for example, that climate change increased the likelihood of a heat wave by 2 times, so it's 2 times more likely to occur, it doesn't mean that the impact that it caused is twice more likely. There's a lot more layers underneath that can change that impact. But climate change is definitely a factor.
Yes, so it's definitely a factor, but then we have all these other issues that we have to consider that play a role in modifying the scale and the magnitude of the impact that you have to sort of consider. And you would have to sort of have built a nice sort of a link of trying to disentangle and understand what exactly is the contribution of climate change.
And then I guess the final or the next equally complicated and contentious point is, having done the attribution, having identified the extent of the loss and damage, who's going to pay for this?
Ooh. No one knows. This is the thing, right? Like, we don't really have a way of doing that properly and consistently, I think is, right.
So I guess, I'll reveal what I'm thinking here, which is, Joyce, in a previous episode, we spoke about some research that Sarah was involved in, which was looking at quantifying the emissions from an individual fossil fuel project in Australia, what the contributions of that individual project would be to global warming, and then what some of the adverse impacts would be on human health and on ecosystems. And people were really interested in this research from a climate litigation perspective. Like, could this be used in, court cases to halt fossil fuel projects? On the flip side of that, loss and damage has been introduced as part of the COPs, which is the United Nations, what is the acronym?
Conference
of
Parties,
signatories to the UN Climate Change Accords, etc., etc. And, I think in a recent COP, a loss and damage fund was theoretically established. And I realize we're straying outside of all of our areas of expertise now and getting into politics and
I have opinions.
Sarah has opinions, but I think, Joyce, if you'd like to, as our guest, you're very welcome to volunteer your views and opinions first, and then we'll get into it.
Yeah, I have opinions too. So I have been part of this process myself as well. And I think I introduced myself by saying that on top of being a scientist at Imperial College London, I do these other sort of technical advice to policy processes back in my country. And I happen to work with people in this sort of the space of the COP or the loss and damage. And also I have been speaking with lawyers, or some lawyers have wanted to speak with me, and I didn't say no. I said, okay, we can chat about how they can use attribution science to support some of the cases that they're trying to build or to pursue. And it's really them just exploring and saying, how can we use this evidence? Because central to climate litigation is attribution science. You need the evidence. You can't take a case. I mean, as we would assume, is that you can't stand before a court without evidence on the case you're trying to defend or to pursue. And so I'll start with the loss and damage discussion. So I've been part of the loss and damage negotiations and discussions, and this is more of like it's more of a justice issue, because it's really thinking about who is responsible for the climate crisis and who is the recipient or who is being affected by this crisis. And you find that in most cases, it's the most vulnerable people who are less responsible that are affected the most. And so that becomes a problem of justice, right? Like trying to say, can people who are responsible for the mess be held accountable or liable for these harms? So in the UNFCCC process, it's been about how do we support the most vulnerable communities, and looking at nations or organizations that are deemed the most responsible for the crisis in the sense of their contribution to the warming, remember we said this is the baseline is from the industrial period. So it's really about whose industrial activities or whose activities over time have really contributed to this mess. And could they be asked to support communities who are experiencing these losses and damages? And we said for some of them it's irreversible, and for some of them, if it's reversible, it means they have to completely change the way they do things. And some would need to rehabilitate, to reconstruct, to change their livelihoods that are no longer sustainable. So it's really about how do we support those communities who in most cases don't have low adaptive capacity to some of these impacts, and their governments are continually as well digging into their pockets to respond to these disasters. So you find that for most of these countries or regions, they are sinking into debt because now we have these recurrent back-to-back crises, disasters that they have to respond to. And it means that they might, in some cases, reallocate resources that are meant for critical services like health and education to respond to disasters. And so it really brings in the question of how can countries that are liable, or regions that are, or organizations that are liable for this, take this responsibility and help these communities to address some of these harms. And on the legal front, it's the same case. It's only that you are taking these particular individual corporates or countries in to some extent. And this is just really for loss and damage. There are many environmental cases that are happening, like people like suing, like national cases where countries are like communities are suing their national governments for lack of duty of care, or putting in enough measures to help them adapt, or just putting not complying with their NDCs, or like there are many cases, but the one that I'm focusing on now is the one on loss and damage, which mainly is countries having that in a jurisdiction that is not in their own within their own territory, but really pursuing actors who they understand as most responsible for the crisis and for the losses and damages. In those cases, communities would use attribution science to first understand, or scientists who would support them would try to help them by providing the science that sort of does the source attribution, as you had said. So if you're taking like an oil major, for example, so we just use an example of Total, or what's the biggest oil major in Australia?
Might be Santos, maybe.
So basically, you would want to understand what's the contribution of that actor. So you're doing more like what's the source attribution, and you're saying so what is their contribution to the current warming? Like what have they been responsible for, sort of cumulatively for a long time since they started their operations till now? And then you go to the steps, so you have to get the evidence of the event, of the physical hazard, and then you have to sort of now go to the losses and damages and try to understand how much of that is related or can be attributed to the activities of that actor. And so communities would use that evidence in court to seek for reparations and compensations to support them to address and respond to the harms.
So Andrew King, our dear friend Andrew King, wrote a paper a number of years ago now saying that attribution was not ready for loss and damage. What are your thoughts on that? Has that changed now? Because I think that paper was written, gosh, we'd be pushing 10 years ago now.
It was a controversial paper. To me, some of the disagreement made sense, but some of them didn't. And I think it's just because there was a bit of misunderstanding. An example of that is that when we say that it's not ready enough, we just meant that for some regions that are still experiencing these challenges that we've talked about today.
Yeah. Okay. Yeah.
For them, this kind of science will not. So if it's a requirement, for example, to access losses and damages. So if, for example, you're told, if we're going to pay for the damages from this flooding event, you have to tell us whether attribution science, whether climate change played a role or not. We thought that would be a huge burden to communities, and especially for those communities where the data is not good, the models are not good, there's no expertise to do the data. And I think that was the main message from that paper. But I think they are And I know there's pushback saying, oh, but we have reanalysis and we have graded data and we have all that. But I think it's been very clear from our discussion today that that's not entirely true. That if we have reanalysis, it means it's good enough and it's representative and it's yeah.
It's just worth pointing out, I don't think we've mentioned before on the podcast what a reanalysis is. And it's just for the benefit of anyone who's listening, a reanalysis is a mixture of observations and a model. So where observations don't exist in space and time, a model fills in the gaps. So you can imagine over parts of the world where there are no observations, it's all model that we're looking at. And from one product to another, it's a different model. So that's why they don't work often very well over regions where we don't have data. Hence, attribution can't be done properly because we don't really know what actually happened on the ground.
Quite right. Joyce, I spotted on your LinkedIn a phrase that I really liked, which was decolonize to decarbonize. And we've touched on this already today, but from the Industrial Revolution onwards, the climate crisis that we're now living through is so closely linked to colonialism. Do you think that's something, and you straddle many different fields, so the climate science, the loss and damage, do you think that this legacy of colonialism being such a big cause of the climate crisis we're all now facing, is that something that's properly recognized around the world, or are we yet to have a real reckoning with that?
I think it depends on who you ask, whether they have that understanding or not. But for me, for example, I know very well that it's these historical legacies, colonial legacies, that continue to shape, that generated and continue to shape the climate crisis, right? So these extractive behavior and using resources, so continue to exploit resources in not an equitable manner, and not recognizing that actually these resources that we've used for so many years to build our economies, and there are other regions that didn't exploit these resources that they're still using and not moving away from it, is really just propagating the issues that we've seen over time. And that is fueling the crisis that we have. So there's a lot of decolonizing to do that needs to happen before we can even decarbonize.
We spoke to Andrew and Aditya today about the carbon budget, and I'm thinking, I don't think I've ever seen a representation of this, but I'm sure it exists. Like, when we think about all the carbon we've already burned, what proportion of that is from advanced economies? And what proportion of that is from the developing world? And I'm sure it is wildly
Exactly. In fact, advanced economies don't have a budget. I mean, they ran out of their budget. They don't have a quota. So they've depleted. So basically what they need to be doing is they need to be closing their taps, like shutting their taps completely, to give space for others if they still want to use this same resource to develop. So like there's no room for them to continue exploiting these resources and using these resources.
It really sucks.
Woodside.
Yeah, Woodside et al., all of your friends. Yeah. Oh, that's really awkward.
I would like to hopefully to pivot to something that's slightly more optimistic, or at least productive, which is, Joyce, you might know that Sarah has recently volunteered herself as tribute, signing up as a coordinating lead author for the Intergovernmental Panel on Climate Change's 7th assessment report. And I believe that you were... Way. Good luck with that. What have I done?
So I'm actually working with Freddie Otto, who Joyce works very closely with at World Weather Attribution.
And Joyce, you were the lead for the special report on climate change and land, working on desertification. So we have mentioned them before on the show, but this might be someone's first episode of Totally Cooked. So could you tell us a little bit about what the IPCC does and what your experience of working with it was like, please?
Yeah. So I have now sort of had like two hats, so two different sort of capacities at the IPCC. In the 6th assessment cycle, as you said, I was a lead author for one of the special reports. And in this cycle, a focal point. So these are very different roles. So a focal point, for example, we approve the outline of the reports. So it's more of the sort of the overall overseer of the process. And so for example, we approve the reports, we approve the outline, we approve the budget, we decide on where sort of some of the meetings will be held and stuff like that. And so I'm in that role now. Even last week, we had a bureau meeting in Geneva where we're discussing about, but it was more for the bureaus. Just because Kenya has a bureau member, we normally accompany our bureau member. Governments accompany a bureau member to the bureau meetings. And next month, we have a panel meeting in Bangkok where we will discuss many other things that affect what Sarah and Freddie and the rest are doing.
So yeah, Joyce, you've got your two hats, and one of your hats is deciding where Sarah's going to be meeting, and then you've also been involved in the process of actually producing a report. And how did you find that? Was it challenging? Was it rewarding? Was it stressful? What are your recollections of that?
It was very interesting, actually. It's Sarah. I'm not sure this is your first time, but for me it was very interesting, like meeting with really sort of global experts in the field that you're writing and you're part of, and really getting to like exchange ideas, exchange knowledge, talk. Like being in these meetings so to me really just the experience of meeting other experts and engaging with them was just like it was fantastic. I mean, of course, it comes with a lot of work and dedication, and because we do this pro bono, of course, and sometimes you're writing big reports, it requires some time, and maybe you have other competing full-time responsibilities. And if you don't have, say, like a postdoc or someone like a research assistant in your team, it might be a little bit of a stretch. But I could say, like, just overall, it's a very good experience contributing your knowledge to these documents or these reports that are used by governments to make decisions. To me, it's really fantastic. And even now, being on the other side of sort of the policy or the overseeing arm of the IPCC is really very nice as well, like being part of the group that sort of agrees on the outline, like what do governments want to know? What information do they require to make their policies, and how climate change is affecting those, and being part of that team that sort of being like goes through that process of approving that outline, and also saying this is a report that will work for us or not, like approving the reports as well. It's a tedious. It's also it's a very political process as well, but it's interesting. So yeah, I think the word here is interesting. It might be challenging sometimes, and especially you have to discuss political issues and interest and stuff like that, which unfortunately shouldn't be happening in a science body. But I understand. I've come to understand now that politics is everywhere, and so it's almost part of everything we do. But we try to minimize these politics, not sort of to affect the integrity of the body and the sort of the credibility of the reports that come out of the process.
So I was just interested to know, because I saw that you studied science at undergraduate in Nairobi, and then you worked at the Kenya Meteorological Department. What was your motivation for moving into the world of weather and climate science? Was it something that you were always interested in, or did it happen by accident? This is a question I usually ask people, and I'm always interested in the story.
So yeah, I did. So my undergrad is in meteorology at University of Nairobi, and then I worked as a meteorologist at the Met Office in Kenya, so the Kenya Meteorological Department. And then I went to University of Cape Town to do my master's and PhD in attribution of extremes. So I've always been passionate with environment and climate, and that I started that in like high school, and I had this very interesting geography teacher. It sort of built my interest of environment and science. And I think the most fascinating one for me was really the air, so the atmosphere, the air above us, and how that interacts with the environment itself to produce the weather that we see, And so I went on to do my undergrad in meteorology. I remember that time, it was one of these courses that were very rare. Like people would be like, "You're doing what? What's that again?" And so I did my undergrad, very interesting, and then I went to the Met Office, and I knew for sure that I wanted to do something in climate, but I knew as well that it has to be something that really looks at sort of analyzes the climate itself, not like looking at sort of the social aspects of it. But to get there or to actualize that vision wasn't very easy because attribution science, no one was offering it in the continent. But one interesting morning, my boss calls me and says, "Hey, Joyce, I received an email. There's a group from Oxford working with a team from University of Cape Town where they want to come to Kenya. They're coming to the Kenya Red Cross, and they also want to visit our department. They also want to see whether they can organize a workshop where we can bring a few stakeholders together. Please, can you help me?" And I didn't know I didn't have so much details of this this project or this initiative. But I said, yeah, sure. It was also a way of mentoring me to be like, like to start learning to do these things, to engage with others, experts and stuff like that. So I responded to that email and I said, hey, it's going to be me who will be receiving you, supporting sort of your visit. And actually, we ended up organizing the workshop. It was a very brief workshop. We ended up organizing, and then we invited a few stakeholders here and there. So I organized this meeting, and these guys were like, oh, we have this interesting project. We would like to see whether we can collaborate with the Met Office and the Climate Change Directorate and the Kenya Red Cross. And I attend the meeting, and guess who was speaking about science?
Freddie Otto.
Freddie Otto. So Freddie had a session in the morning, and he was explaining about this science of attribution, and he was talking about rolling a dice, and you're saying you see the droughts that we see in East Africa, it's like this dice has been loaded, and it was just, he gave it in a very nice story format, and it was very interesting. And I was like, wow, this science is fascinating. And during lunchtime, I went to her and I said, oh, wow, I really enjoyed your talk. It was interesting. And she wanted to learn more about like me and what I do. And she was like, oh, let's continue this conversation later in the evening. And we continued that conversation. And she was asking me, so what have you done? And I was explaining to her about like when you join, and I think it happens to all Met officers, when you join, there's normally a course. It's a requirement by WMO to do like an operational training course. It's called OTS. And I was saying to others, as part of my 6-month training, joining the Met Office, I wrote, it's called a term paper. So I wrote a term paper on the impacts of climate change on water resources in Kenya. And she was like, oh, wow, can you share that? And then I shared that. And she read it. And so by the end of that evening, she was like, do you mind coming to Oxford to meet my team?
Yeah.
Is this something you would consider? And I said, oh, yeah, I mean, it sounds like an interesting
Just casually, sure, I'll come.
Yeah, it was
Obviously
very casual. I didn't even know she was serious. We were like, just like chatting, and she was like, actually, you might as well come to my office, and you can speak to other people that are not me, and you can even see what they're doing, and you can spend time with them. And within no time, I think in like a month or two, I was already going to Oxford to meet her team.
Yeah, right.
And I definitely knew this is what I wanted to do, but I knew that I wanted to do like a master's and a PhD to like really understand more exactly is this field. Almost have like a deep understanding and really be part of sort of the community. And the rest was history.
Did you do your PhD with Freddie, or did you do it in Africa?
Yeah, so the PhD was a joint project between University of Cape Town and University of Oxford. So I would spend time in both institutions, but it was a requirement to register in one. And so I chose to register at the University of Cape Town because also I wanted this very African focus as well in terms of...
Of course.
I think the lesson for anyone listening at home, if there are PhD students, undergraduates, anyone listening who's at that stage of their career, it's so important to chat to people,
Absolutely.
At the conferences you go to, annoy people, ask them questions, be curious. Many of them will be curious too. And your story, it's a great story, Joyce, and it's, that's quite an unusual example, but it's not uncommon for relationships to develop in that kind of way, for just two people to find each other and vibe with each other, and for really cool things to come of it. So it was definitely more than 3 minutes, but it was a great condensed version. And I feel like what we need in the future is like a follow-up episode of Joyce's journey, right from those geography classes all the way through to where you are now. So I've enjoyed speaking to you so much, and we could have gone for ages today. So thank you so much for giving us so much time and so much cool information and good stories.
Thank you so much. I really, really, really had fun here. This was an easy, relaxed conversation. I loved it. I loved every bit of it.
That's it for today. Thanks very much to Joyce for coming on the show. Please join us for the next episode of Totally Cooked.
And we'll tackle the climate crisis together.
Yay.
Yay.